Hello, boys and girls. Welcome back to another day of Number Corner. Yesterday was an e-learning day, the 22nd, and so you didn't see me, but if you had work to complete, hopefully you've completed that. Or maybe if you've missed some Number Corner videos, hopefully you've watched them and participated and done whatever it is that you needed to get done. Today is the 23rd, and we are going to be doing a problem string. I'm going to jump right into the problem string because we all know how much time sometimes a problem string takes, especially doing it virtually. And we want to get through as many questions as possible. So I have updated our calendar collector for us already, and we'll talk about that another time, not today, and updated our calendar grid so that we can focus specifically or strictly on our problem string. Before we do, though, I want you to think about money, fractions, and decimals. And I'm going to ask you some questions, and hopefully you can think of the answer really quickly since we've done a lot of work with that this year so far. How many cents are in a dollar? Easy one. 100 cents, which is $1. So then how many cents is half of a dollar? Yeah, 50 cents. How about 1/4 of a dollar? 1/4. You got it, 25 cents. And then 3/4 then would be, or 3/4 would be 25 times 3, 75 cents. This might be tricky. What is 1/5 of a dollar? So you take 100 cents, you divide it into 5 equal groups. What are you going to get? Yeah, 20 cents in each group. So then if 1/5 is 20 cents, what is 3/5 of a dollar? Good, 60 cents, because 20 plus 20 plus 20 is 60 cents, or 0.60 for 60 hundredths. All right, so you can go ahead and open up your Number Corner notebook to a blank page so that you can fill out or do some work with me while we go through our questions. And while you're getting that out, let me just quickly give you the context for today's string, which is the simple fact of looking for change, whether it's in between couch cushions or in pockets, on the street, wherever, in the laundry. I found some coins in my laundry room, or anywhere. You're looking for coins and you find money and you're trying to figure out how much you found. So we're going to be talking about money, but we're going to be talking about it in the context of adding fractions. So here we go. Very first one is 1/4 plus 1/2. And so earlier we talked about 1/4, we talked about a half. It says one day you found half of a dollar, and then you found a quarter. How much money did you find? So if you see 1/4 plus 1/2, maybe it doesn't have this context written around it. You can always give it a context. And with fours and halves, it's really easy to think about money because it just makes it so much easier to solve. So that's what we're going to do when we think about solving for 1/4 plus 1/2. So I'm going to add a text box here, and we'll do this one together, kind of, before I tell you to work on it, and then we'll talk about it. So if we're thinking in terms of money, in cents, 1/4 is 25 cents. And then we have a half, which is 50 cents. And that's going to give us how much money? 75 cents. Easy peasy, lemon squeezy. So then what if I thought about in terms of a coin? So we're talking about money, maybe not amounts or value specifically, but maybe just the fact that I have a coin. I would have 1/4 plus 2/4 is going to give me 3/4. You guys agree? Perfect. And if I want to think about decimals, I would have 25 cents plus 50 cents is still equal to 75 cents. I'm just writing it in different ways, and I'm talking to you about the different ways that you could solve this problem so that as we go through them, I want you thinking about which one might be easiest for you when solving these problems. I could also think about it and make common denominators. We've talked a lot about denominators of 100. So 1/4 is 25 hundredths. And then we have 1/2, which is 50 hundredths. And we know that because of money, which gives us 75 hundredths. Very last thing is the least common denominator would be 4. So I could think about it in common denominators of 4. So I'd have 1/4, and then I'd have 2/4 because I know that 1/2 is equivalent to 2/4, and that is going to give me 3/4, which is still 75 cents. So it depends on what the question asks. If it's 1/4 plus 1/2, I would have to say 3/4. That would be my answer. Asking how much money? 75 cents or 3/4. So context is going to tell you everything or help you think about how to solve it. And then we'll have to figure out, well, what form are we going to write our answer in? So let's look at the second problem. 1 1/4 plus 1/2. See if you can solve that fairly quickly. Now you're finding $1 and 1/4 and then 1/2 $1. How much money is it? Right, we can use what we did up here. We already know that 1 1/4 plus 1/2 is 75 cents, and now I'm just adding $1 to it. So what should I have? I should have $1.75. So I'm actually gonna, for the sake of time here, I'm actually gonna break up 1 1/4 because it's the same thing as saying I have 1 plus 1/4 plus 1/2, because 1 1/4 is the same meaning as saying 1 whole and 1/4 of something else. And so since I know that 1/4 plus 1/2 already, then now I can just add 1 to it. Seems easy, right? Which is going to give me $1.75. Or I can write it as a fraction, which would then be 1 3/4. And I get 1 3/4 because I know that 3/4 is the same thing as 75 cents. Or I could change my, remember we changed our 1/2 to 4ths for common denominators, and we got 3/4, and I just have a 1 with it. So a couple different ways. Let's look at the next one. 3/4 plus 1/2. Now you find 3/4 and then 1/2 $1. How much money is that? We know 3/4 is 3/4. It says we found 3/4. We know 1/2 is the same thing as 2/4, which now means we have 5/4, which is $1.25. There's another way you could solve it, though. What could you do? Did anybody think about 3/4 as 3 times 1/4? Isn't that what 3/4 is? We've been working on multiplying a whole number times a unit fraction. And so that's exactly what it is. It's 3 times 1/4. That's 3/4. And then we still have to add it to 1/2. So I could do 1/4 plus 1/2. And no, I can, because we got to think about order of operations. So maybe it is the best thing to do by thinking about it in terms of quarters. That, or we can break it down into cents. 75 cents plus 50 cents equals 125 cents. So let me add that to my thing here. 75 cents plus 50 cents equals 125 cents, which is the same thing as $1.25. That is how much money they found. So really breaking that up into a multiplication problem wasn't very helpful. So maybe we should not have done that. Let's look at the next one. Oh, now I have 1 3/4 plus 1/2. Right, we're just increasing by one whole dollar. So I'd have 1 plus 3/4 plus a half. We know 3/4 plus a half is $1.25, and now I'm adding another dollar to it. So how much money do I have? I have $2.25, and I'm going to write that out for those of you who are following along, but maybe I'm talking too fast. I hope that I'm not. 1 3/4 plus 1/2 is the same thing as saying 1 plus 3/4 plus 1/2. We know 3/4 plus 1/2. What do we say 3/4 plus 1/2 is? Yeah, it's 125 cents or $1.25. And now I'm just adding another whole dollar to it, which is $2.25. Thinking about problems in terms of money makes things a lot easier to solve. So let's keep it moving. Oh, now I have a half plus a fifth, but let's put it in context. Maybe it'll help us think through it. You find half of a dollar one day, and then you find 2 dimes. How much money did they find altogether? That makes it really easy because 2 dimes is worth how much? 20 cents. And half of a dollar is 50 cents. So now how much money do I have? Yeah, so I have 50 cents plus 20 cents, which equals 70 cents. And I'm going to write it as a decimal. You with me? Great. We are moving right along. See if you can try this one then. 1/2 plus 4/5. Now, instead of finding 2 dimes, which is 1/5, you find 8 dimes because that's 4/5. So how much money do we now have? I hope I hear somebody shouting out at the computer, even though it may feel weird. But you guys need to know this information. 1/2. So let's think about money. 1/2 is 50 cents, and I'm just recording it in different ways because I want you to see how all those ways relate to one another. And then we have 80 cents. 50 cents plus 80 cents. How much is it? I'm going to even break up 50 cents or 80 cents. 80 cents is the same thing as saying 50 cents plus another 30 cents, right? 50 cents plus 50 cents is $1, and then I still have 30 cents. So I could say I have $1.30, and I could also say that I have 130 cents. You put my dollar symbol here. I could say 130 cents. I could, as a, how would I write that as a fraction or as a mixed number? Good. It is 1 3/10, or 1 30 hundredths. Either one would work for Miss Trammell. I really want you guys to feel comfortable thinking about money because money is like everywhere. So many things revolves around money. You want to make sure you understand it really good. 2 more, guys. We are rocking and rolling today, but I want to stress one of the big ideas. When you are adding fractions, sometimes it helps you express those fractions in a form that's going to allow you to combine them. So I couldn't just add straight across here because they don't have like denominators. But I can combine them when I'm talking about the same thing, which is money in this case. And that gives me my common denominators. So if you hadn't thought about that or figured that out thus far, I want to stress that to you. You have to think about adding fractions in a form that's going to allow you to combine them. And the easiest way for these problems specifically, because of the denominators, is to think about money. or to write them as fractions with the same denominator, kind of like I showed you up here, some of the ways to think about them, with 100 as a denominator or fourths as a denominator. And we could have done that here. And I'm going to do that just to remind you. So 1/2 is the same thing as saying 50 hundredths. 4/5 is the same thing as saying 80 hundredths. And I know that because 4/5 is 8 dimes, which is worth 80 cents. All right, so use that knowledge to help you solve this problem. 2 1/2 plus 4/5. One day, my sister found $2 and a $1/2, and I found 8 dimes. How much money did we find? We gotta make it into a form that is going to allow you to combine them. That means having like denominator or like terms. So that's why we translated it to money. 2 1/2 is the same thing as saying what? Well, it says it in the problem is $2. So I'm going to write that. It's the same thing as saying $2 and 50 cents. So it says she found $2 and $1/2. Okay? And then I found 8 dimes, and 8 dimes is worth 80 cents. So what's $2.50 plus 80 cents? It is $3 and $3.30. But if this were just a regular, and I like to call them just a naked computation problem without any context, the answer I assure you is probably expected to be in fractional form because that's how it was given to you. So let's translate this into a fraction. $3.30 is the same thing as saying 3 3 hundredths. Or I could say 3 3/10. Remember how we talked about finding equivalent fractions with tenths and hundredths? And that has the same value. If we're talking about money, it's the same thing. It's 3 whole dollars and then 3/10 of a dollar, or 30 hundredths of a dollar. So we can go back here and we can write a fraction for here, which would be 7/10 or 70 hundredths. Same thing, 7 dimes out of 10 dimes or 70 pennies. I could do that here. What would it be? For $2.25, 2 and then 25 cents is worth what fraction of a dollar? 2 1/4. So just be mindful that we are putting it into a context that allows us to combine them, giving it like terms or like denominators. But if we were to see this on a math test or a state test of some kind, we need to also know how to figure out the fractional answer. So for the last one, for today, 2 1/2 plus 3/5. It says, one day my sister found $2 and a $1/2, so we kind of did this earlier. And then I found 6 dimes. So you think about how problem strings are set up. Usually the problem's related. So now instead of adding 4/5, I'm adding 3/5, which means I could essentially just take away 20 cents from this answer. Go ahead and work it out. Right, you may see me working things out here. And it's just me just showing you some different ways of thinking about things, okay? So I chose, yes, we could have found the connection. So instead of 8 dimes, we have 6 dimes. So that means we're subtracting 20 cents from what we got. And we know that will be $3 and 10 cents. But you could also think about it in terms of finding common denominators like we've done earlier. Or Think about it in terms of coins. So here's common denominators. I have 2 wholes, 5/10, and then my 6/10, which I broke up into 5/10 and 1/10. 5/10 plus 5/10 is 10/10, which is 1 whole. So I have 2 plus 1 whole plus another 10th, which is 3 and 1/10. Or I could think about it like this. I have $2 plus 1/2 is 50, or I'm going to say 5 dimes because that's 50 cents. And then I have 3/5, and we know that 1 dime is a 10th, but 2 dimes is a 5th. So here's a 5th, here's a 5th, here's a 5th. So I have 6 dimes, and I can combine that to being $2 and 11 dimes, and we'd have to break our 11 dimes up into 10 dimes and 1 dime, which still gives me another $1 and 1 dime left over. Which is still $3.10. All right, we've done a lot of work with fractions today, specifically adding fractions. I hope that you followed along, and if not, maybe if you have free time or if you're really struggling, you should go back and rewatch this video because you guys need to understand how to add fractions. We will do one more problem string this month with fractions. Until then, you guys have a great evening, afternoon, or day, and I'll see you tomorrow.